Hello, 8th graders. This is Teacher Monica, and welcome to our learning session. Have you ever wondered how they design their work for carpenters, architects, and engineers? In making their designs, what factors are considered? The usage in real life of parallelism and perpendicularity of lines necessitates the deductive establishment of these principles. This video lesson is designed to answer the question that runs in our mind: how can we establish parallelism or perpendicularity of lines? At the end of this lesson, you should be able to construct a perpendicular bisector of a given segment and construct an angle bisector of a given angle. Let's discuss first about perpendicular bisector. Perpendicular bisector theorem states that if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of a segment. Say, for example, in this figure, from the illustration, we have line segment MA is perpendicular to line segment GD, and line segment AG is congruent to line segment AD. Therefore, line segment MG is equal to line segment MD. Next, we have the converse of a perpendicular bisector theorem. It says that if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of a segment. Look at again this figure. In the illustration, if line segment MG is equal to line segment MD, then line segment MA is perpendicular to line segment GD, and line segment AG is congruent to line segment AD. Now, take a look at these examples. Line segment OQ is perpendicular to line segment PR. The ticks show that line segment QP and line segment QR are congruent. Now, if line segment OP measures 6 centimeters, what is the measure of line segment OR? Yes, it is also 6 centimeters because they must be equal. So for example number 2, line segment SE is perpendicular to line segment RX. If line segment EX measures 10 centimeters, what is the measure of line segment RX? Correct. It is 20 centimeters because line segment ER must have the measure of 10 centimeters because it is congruent to line segment EX. Now let's discuss angle bisector. Now let's discuss angle bisector theorem. It states that if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. Say, for example, in this figure, the illustration simply shows that if angle DAC is congruent to angle BAC, then therefore DC is equal to BC. Next, we have the converse of the angle bisector theorem. It states that if a point in the interior of an angle is equidistant from the sides of the angle than it is on the bisector of the angle. Again, look at this figure. The illustration shows that if DC is equal to BC, then angle DAC is congruent to angle BAC. Example, if angle DAC measures 12.8 degrees, what is X? Very good. It is 12.8 degrees also because they are congruent. Next we have, if angle SEX and angle RES are congruent and line segment EX is equal to 74, what is the measure of line segment ER? Very good. It is also 74 because they are equidistant. Before we end, let us remember that when a triangle is bisected by a line, then the triangle is cut into two equal triangles. Thus, the segment bisected by a perpendicular line is equidistant to another segment. And if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. The angle bisector theorem helps you find unknown lengths of sides of triangles because an angle bisector divides the side opposite that angle into two segments that are proportional to the triangle's other two sides. Now, we have discussed in our lesson about congruence and equal measurements. But for us, let us be reminded that all of us do not have equal talent, but all of us should have an equal opportunity to develop our talent. So that ends our session for today, students. Until next time.